You made it to the final set of challenge problems, and here we're looking at trigonometry. So in our kind of core skills, we looked at using the unit circle and using SOHCAHTOA. So what can we do for our challenge problems? I still have a lot to learn in terms of the unit circle and how to use that for more challenging stuff, but there's actually a lot you can do for that. I will need to do that later in the semester. Right now, we're just gonna look at some SOHCAHTOA stuff, because we know SOHCAHTOA, all right, and we're gonna look at application problems. All right, so all these application problems are gonna just be some real world scenario. Real world is in quotes because like how often do these things actually happen, but they're things that could happen in the real world. All right, so here we have Amira leans a 16-foot ladder against the wall, and it tells us it forms an 66-degree angle with the ground. What's the horizontal distance between the base of the ladder and the bottom? So we always want to draw a picture when we're doing these, because the picture is going to help us see a right triangle. So we have this building with a roof. We're leaning this ladder against it. The angle the ladder makes with the ground, so this angle here is 66. We also know that the ladder itself is 16 feet long. And we want to know how far is the base of the ladder from the wall. So if I draw this without all the pictorial stuff, it basically looks like this. We have a 16 diagonal, 66 angle, and the x that we're looking for there. And this just looks like any problem I would have given you before. Use SOHCAHTOA. So here this is cosine of 66 is adjacent over hypotenuse. Multiply both sides by 16. And I get that x is 16 cosine of 66. All right, make sure you double check that your calculator is in degrees, because we're using degrees, and I get 6 point, how many does it, once to the nearest hundredth of a foot, which is 2 decimal places, 5, 1. Oh my goodness, feet. So this is just like the problems we were doing before, just now you have to draw a picture and kind of figure out what the sides are. All right, so here, introduce the new term, angle of elevation. So if you look flat, that's just the horizon. If you look up from that angle, that's your angle of elevation. If you were to look down from that angle, that's your angle of depression. All right, so if you see any of those, just know you draw a flat line and go down or up based on which word they're using. All right, so we have this angle, or this tree. The angle of elevation, so from flat, looking up to the tree, it's 52 degrees. And you are 82 feet from the bottom of the tree. So you're kind of standing here, and you're looking up at an angle of 52. And what do I want to know? How tall is the tree? So this is what I'm trying to figure out. So I can see that this is going to be a tangent problem, because I don't know the hypotenuse. So tangent of my 52-degree angle is TOA x over 82. In this case, I multiply both sides by 82. And I get x is, let's see, I'll type this in. 82 tangent of 52. Again, double checking my calculator is in degrees. I get 104.96 feet. So these first two problems are all about just drawing the picture correctly, right? Making sure you have kind of the elements labeled in the correct place. All right, just think about in context of the problem, what you should be labeling where, and that'll get you to your right triangle. And once you have a right triangle, we know you can do it because you've already done SOHCAHTOA before. But here's the new stuff. Other than it just being a word problem, is now we're going to have these kind of two different angles. So a boat is heading towards a lighthouse, or Dominic is watching from a vertical distance of 114 above. Okay, so let's see. We have this lighthouse, and Dominic's standing up here, and that is 114 feet above the water. He measured an angle of depression to the boat of point A to be 6 degrees. So remember, angle of depression, you're going to start off with a flat, and you're going to go down. All right, so this is the angle of depression of 6 degrees, and that's where the boat is at point A. At some time later, he measures another measurement and finds the angle of depression of the boat is now 32. Right, so in flat to down, 32 is a bigger angle, so that's going to be 32. And now my boat is here at point B. Find the distance from A to B. So the answer I'm trying to find is right here. Right. So how can I do this problem? Well, if I look at this x is a part of this triangle here. And some people might say, well, I could subtract the 6-degree angle from 32 and figure out that that little blue angle is 26 degrees and use that. But the problem with that blue triangle I just drew, it's not a right triangle. and we can only use SOHCAHTOA with right triangles. So I need to break this problem down into right triangles to figure out what I can do. And the way I'm going to do that is I can make this green right triangle here, which is this smaller right triangle, and that'll give me this. Let's call this like lowercase b. Then I can make this bigger blue right triangle. Actually, let's make it red because I already made a blue right triangle. I have this bigger red right triangle, and I figure out the whole bottom of that. Let's call it A. If I know A and B, I can take A minus B, and if I get A and I take away the B part, I get the x value I want. Right. So how am I going to do that? Well, let's start with the blue triangle. The angle up here is 32, which means the angle actually in the triangle is 58. This is 114, and this is x, so this is going to be a tangent situation. Tangent of 58 is x over 114, multiplied by 114. I get x is 114, tangent of 58, 182.44. Now I'm going to do the same thing for this red triangle. The height of the dominant doesn't change. This angle of depression was 6, so the actual angle in my right triangle is 84. I'm finding this. This was B. That's just going to be tangent of 84 equals x over 114 to 114 tangent of 84 equals x, and x is, and I should have been calling them B and A to avoid confusion, but I just realized that a little too late. So 114 tangent of 84, that's 1084.64. All right, and this was A, and this was B. So if I take A minus B, I'm going to get 1084.64 minus 182.44. I get 902.2, but it asks me to round to the nearest foot, so I'm just going to do 902 feet. All right, so this is the brand new thing. This is actually like the part of the challenge problem, is now using two different right triangles to figure out something that's not in a right triangle. If you just think about where are your right triangles, where can you use SOHCAHTOA to figure out stuff, you can actually figure out more information you need and try to put it all together. But your goal is finally get down to that answer that's not in the right triangle. So here's another one. Trying to find the height of a radio tower. Stands at a horizontal distance 21 meters from the building. All right, so there's this radio tower on a building, and Lucy is out here 21 meters from it standing. The angle of elevation from our eyes to the roof is 21, so angle of elevation is flat to the roof is 21. Angle of elevation to the top of the antenna, so flat up to the antenna, is 36. Right. How tall is the antenna? All right, they also give this information. We'll see if that's important at the end. Like, that's basically just this set distance below here. It doesn't look like that should be important, right, because there's the eye line is just a little bit higher than the start. All right, but we're trying to find this distance. We can see we can't find that straight away because this is not a right triangle. So with our blue right triangle, we can figure out the height of the building. It's called B. With the green right triangle, I can figure out the total height. Let's call that T for total height. All right, so let's figure out B first. All right, we know we don't have any information about the hypotenuse. It's going to be tangent of the angle 21 is B over 21. Those are both 21. Yeah. And 21 tangent of 21 equals B. For T, it's going to be tangent of the bigger angle, 36, is TOA, T over 21, multiplied by 21 is 36. Right. And now the actual answer, the height of the antenna, is the full height, T minus B. If I type those into the calculator, 21 tangent of 36 minus 21 tangent, and you can type these in separately and then subtract them. I'm just doing it all at once. And then I'm going to round to the nearest meter. So the answer I get is 7.20. Rounding to the nearest meter is 7 meters. So these are all about drawing pictures. Again, drawing a big picture to kind of represent what you're looking at, and then breaking it down into right triangles. All right, you can only look at right triangles. How can you get the information you want from right triangles? And generally it's going to be find two different answers and subtract them. In some rare cases, it's find two answers and add them. I just know that basically for these ones that are a little bit more complicated, when you have two angles in the problem, Jordan's doing two separate SOHCAHTOAs or two different triangles and then adding or subtracting your answers. This is the very final challenge problem. There's like 8 examples for you to try. They're all a little bit different. Try to draw pictures, try to figure out what's going on. And this really works on your logic skills, your SOHCAHTOA skills, your reasoning skills, all that. This is like a great thing to work on to really improve all that stuff.